Hey guys, welcome to the 2013 Level 2 Mechanics paper. This is for Level 2 Physics, and we just might as well get into it. Question 1, motion. Jason spends a day at the amusement park. He stands on a merry-go-round, which turns at a constant speed. The diagram below shows Jason standing on the merry-go-round, which is going around in the clockwise direction. On the diagram above, draw an arrow on Jason to show the direction of his velocity at that point. Alright, so you know that the instantaneous velocity is always 90 degrees to the center of the circle. So basically, what it's saying here, so basically, you know the centripetal force acts towards the center, and basically that's the centripetal force is towards the center, but you know that the instantaneous velocity of Jason is always 90 degrees to that center of the circle, so it's about there. That should be about 90 degrees to the center. So that's his instantaneous velocity. So that's just an achieved question that gets you achieved grade. Shouldn't be too difficult. The radius of the merry-go-round is 4 meters. The merry-go-round takes 15 seconds to do a complete circle. Jason has a mass of 65 kilograms. Calculate the centripetal force needed to keep Jason moving in a circle. Okay, so we know that we're trying to find FC, so that's what we're trying to find, and that equals to mv squared divided by r. Okay, so they're giving you the radius, they give you the mass, but you don't know the velocity. Okay, so you actually need to find the velocity first before you can work out the centripetal force. Okay, so you know that velocity equals to 2 pi r over t, where t is the period, so how long it takes to make one revolution, and you know that 2 pi r is just the circumference of the circle. Okay, so we're going to say 2 pi r, so 2 times pi times 4 divided by the period. So the period, so t equals to, you see, the merry-go-round takes 15 seconds to do a complete revolution around the circle. Okay, so t equals to 15, and that's because it takes 15 seconds to do a complete circle. Okay, so we divide this by 15. So if we use a calculator right here, we can actually calculate the velocity. And we can find out the velocity is v equals to 1.68 meters per second. Okay, so now we've got our velocity. Now that we've got our velocity, and we can now substitute into the v centripetal force equation. So we can say F C is equal to 65, that's the mass, times 1.68 squared divided by the radius, which is 4. And now we can find out our centripetal force is actually, just plug into your calculator. So if you're at home watching, plug into your calculator, and you should be getting 45.86, or just say 45.9 newtons, which equals to 45.9 newtons. And that should be your final answer here, and that should get you in a merit grade. Actually, getting all the way up to here gets you a merit grade. And finding out the correct velocity, so getting all the working included, so all the working, you're getting the v equals to 1.68 meters per second, that gets you an achieved. Okay, alright, moving along. Jason then goes for a ride on the go-kart. Towards the end of the ride, he decelerates at 2.5 meters per second and comes to a stop in 4.2 seconds. By calculating Jason's initial velocity, determine the distance he travels when coming to a stop. Okay, so now we basically just we can use the equations of motion to answer this question. So we know the acceleration. So a equals to negative 2.5. It's negative because it's decelerating, so it's losing speed. So it's negative. We know that the VF is 0 because he comes to a stop. So the final velocity is 0 meters per second. And we know that the time is 4.2 seconds. Okay, so just a challenge, okay? Looking at your formula sheet, we're trying to find the initial velocity, okay? So which equation can we use that has acceleration, final velocity, time, and initial velocity, okay? Pause the video now and to figure it out for yourself, okay? Okay, I'm going to say the answer in 3, 2, 1. Okay, so the easiest formula to use in this situation is VF equals to VI plus AT. This is because there's final velocity. We know final velocity. We're trying to find the initial velocity, which is here. We know the acceleration and we know the time. Okay, therefore this equation is useful to us, and we can use this for our calculations. So we substitute the numbers in, right? So we say 0, final velocity is 0, equals to VI plus AT, but negative 2.5 times 4.2. So negative 2.5 times 4.2, so that's negative 4.5 times 4.2, that's negative 10.5, okay? And a positive and a negative makes a negative, so minus 10.5, okay? Okay, so basically, what minus 10.5 is 0? So that's pretty straightforward, so you can see straight away that VI is 10.5 meters per second, okay? Okay. Sorry, that's a bad S, okay. We found this out now, okay? So now we have to do equations of motions again, okay? So now we're trying to figure out, so now we're going to write down what we know and what we're trying to find out, okay? So once again, we know the acceleration, we know the time, now we know the initial velocity, and now we're trying to find the distance, okay? And we also know the final velocity, so you can really use any formula, really. So we can just say we're going to use, we'll say d equals to initial velocity multiplied by time plus half at squared. So then we're just going to substitute our numbers. So we know VI is 10.5, we know time is 4.2, and we know that acceleration is negative 2.5, and then we just substitute these numbers in and then see what we get, okay? So basically D equals to 10.5 times 4.2, and then I'm going to say add 1, sorry about new line, so negative 2.5 times t squared, which is 4.2. Alright, so now the easiest thing to say now is just plug it into your calculator. So just say plug everything into your calculator and see what you get. Remember to put brackets around your work so the calculator doesn't get confused, okay? It's very important. Okay, so now we can find out distance is actually 22.05 meters. Okay, so for this question, you could have used D equals to VIT plus half AT squared, or you could have used D equals to VI plus VF divided by 2 multiplied by T. So you could have also, I'll just write the equation here. So you could have also used D equals to VI plus VF divided by 2 times by T. So that will give you the exact same answer. So just to prove that it's the same answer, we'll just say D equals to, so initial velocity was 10.5, we figured that out, plus final velocity, we figured out that's 0 here, so 0 divided by 2 and then multiply by 4.2. And if you plug that into your calculator, you should also just get that equals to 22.05. So just double check here, so 10.5 divided by 2 times by 4.2. Yeah, that gives you 22.05. So it's just, so basically if you have all 5 of these, so if you have acceleration, time, initial velocity, and all of these variables are involved, you really can just pick and choose which equation you want to use, okay? So which one is more easier for you is which one you're going to use, okay? So for this question, getting all the way up to 22.5 meters, that's an excellent grade with all the appropriate working, okay? You need to show your working, okay? I cannot stress enough that only a correct answer is only worth an achieved mark, okay? You need to show your working and how you got to your answer, okay? Okay, so to get a merit grade is, getting a merit grade is, by, okay, so a merit grade is basically you made a mistake and then you assume that the initial velocity was 0, and that's a minor mistake, so you go down to merit, okay? To get achieved, you basically just find the velocity. So getting up to here will get you an achieved, okay? With all the appropriate working before will get you an achieved, okay? Alright, moving along. Jason sits on the slide, as shown in the diagram on the right. He is sliding at a constant speed. State the net force on Jason. Okay, so you know that in level 1 mechanics, we learned that if something is going at a constant speed, that means all the forces acting on that object is balanced. And when the forces acting on the object is balanced, that means just like the net force is 0, okay? So basically, the answer to this question is just simply 0 newtons, okay? And that's basically it for I. On the diagram on the left, draw the remaining forces as labeled vectors acting on Jason. FG has been drawn for you. So you should also know that the forces acting on Jason, so there's a reaction force, that's the FR, the reaction force that acts at an angle right here, about 90 degrees to this surface, so about 90 degrees to this slide surface. So this surface, the slide surface, 90 degrees. There's an FR, and there's also a force of friction, okay? Don't forget the force of friction. So the force of friction that's acting backwards, and there's your force of friction. So if we just label this, we can simply just say, we can just simply say F of R, so F of force of reaction force, and we can say F of F, so that's the friction force. Okay, so this is going to be silly. So F of F, and there's F of F, okay? So that's basically it for II. So basically, you have to remember the reaction force acting at 90 degrees from the surface. So you see the slide here? This slide and this arrow should be making a 90 degrees. So right here, that should be 90 degrees. Remember, FG is always acting downwards. So 90 degrees from here, that should be acting down 90 degrees from the ground. And then the force of friction always acts in the opposite direction of the sliding force. There's also a sliding force. You don't need to put the sliding force for this question, but there's, just to let you know, there's also a sliding force that's allowing Jason to slide down. And remember, because the net force is equal to 0, that means the forces are balanced, and this means that the sliding force is equal to the friction force. And because the sliding force is equal to the friction force, that means when you're drawing the vectors, it's important to keep in mind that you need to have exact same size arrows. Well, not exact same size, but it has to be like similar size, enough for the marker to understand that you know that the vectors are equal, okay? So that's important to know, okay? Note that down. Alright, complete and label the vector addition diagram of the forces acting on Jason. He continues to slide at a constant speed. So because he continues to slide at a constant speed, we just say we know that the forces acting on Jason is balanced, okay? And therefore we can just draw the forces out. So we can just say, just draw the arrows out. So we can just say there's an F of F acting in this direction. Remember, just exact same. So this is just, do not get confused by this. It's the exact same thing, but now the slide is not here, okay? So this is basically the exact same thing, okay? So just say there's an F of F acting here at this angle, and then there's an F of R. Remember, the F of R was this way, and it was about, should make a triangle, okay? So more important to know, when the forces are balanced, that means the F of R, the F of F, and the F of G, they should make a closed triangle, okay? So because it's a closed triangle, that means the forces are balanced, okay? You don't have to add any explanations, you just need to label the forces. So you can say F of R here, and you say force of friction here. Okay, so force of friction here, and the force of reaction this way, force of friction this way, and it makes a closed triangle. Okay, the F of G, F of F, and F of R, they will make the closed triangle. Okay, it's important to remember that. Okay. So, gradings for this question. Okay, if you get all the way up to here with the labeled correct forces and everything up, so iron, this is correct, and this is also correct, then you get excellence grade overall. If you only get the 0, you need to get 0 newtons, and you need to get either I or I. Okay, so either one of these will get, and so this plus either this or this will get you a merit grade. Okay, and to get the achieved grade, you only need to get either I, or I. So either one of those three will get you an achieved grade. So either one of them will get you an achieved. Okay. But it's important to remember, like I said, I'll say this one more time. So when you're labeling the vectors, important to keep the little things in mind. For example, the f of r, it acts 90 degrees to the surface. Okay, that means just makes 90 degrees of the slide. Force of gravity always acts directly downwards. Okay, it doesn't act at the angle, it acts downwards, and then makes 90 degrees of the ground. So you see the ground I've drawn here. So this is 90 degrees here. And then f of f always acts in the opposite direction of the sliding force. So you see Jason is sliding down the slide this way. That means the force of friction must be acting this way, in the opposite direction, okay? And because the net forces are balanced, this means that both of these arrows must be approximately the same size, because the friction force is equal to the sliding force, and therefore the forces are balanced, and Jason can move at the constant speed, okay? So it's important to keep all those points in mind, okay? If you want the excellence grade, okay? It's really easy to lose out on the excellence grade in questions like this, okay? So thank you for watching, okay? I have to go now, so thanks for watching, okay? Hope you enjoyed. Any questions, leave it down in the comment below. And please like and subscribe. And thanks for watching. Bye-bye.